In our last video, we talked about the dark matter and theory behind them. In this video, we will discuss on particles that dark matter could be made up of. But at first, how do we know dark matter even exists? If the theories are correct, then dark matter exists everywhere in space. It has also been predicted that our Earth is surrounded by theoretical filaments of dark matter called hairs. There is a famous example by Dr. Brian Greene. When we look at the city at night time through our naked eye or telescope, we can observe the things that are visible to us. However, during the daytime, there are many other objects like buildings, bridges, etc. that were hidden in the dark, which explains how data predicts that dark matter accounts for nearly 95% or total mass of the universe, and rest 5% is visible to us that we can observe. The evidence for the existence of dark matter came in 1922 when scientists noticed a galaxy and its stars. From Newton's law of gravitational force between stars and galaxy, we have this formula, which provides the necessary centripetal force for the stars, which is given by this formula. After doing some algebra, we found that the velocity of stars is directly proportional to its mass. So as the stars moves away from the center of galaxy, its velocity must decrease. Now the total visible mass can be calculated from basic law. From this mass, the velocity of a star is plotted. We obtain the theoretical graph. Further, we can have an observed graph, and we see that there is a vast difference between the theoretical and the observed graph, since the velocity is much higher in case of observed graph than what we have expected. So there must be some additional mass which we cannot observe directly and is the direct evidence for the dark matter existence. If there is mass, then it must be made up of something just like we and our visible mass is made up of electron, proton and neutron. Before we discuss about the possible candidates which are responsible for the mass of dark matter, let us discuss the properties of this particle. So it must be slowly moving particle. It must be dark so that it doesn't emit light. It must be produced during the Big Bang. It must be stable, that's why it doesn't decay, and it gives the correct rotation curve. In our next video, we will discuss about the dark matter candidates, which is going to be pretty much exciting and intrigued. I'll see you guys in the next part of this video. Thank you.